Thanks to CARAHCAST for all that they do for us. We couldn't do this without them, that's for darn sure. And thanks for everyone for attending. This, I think, for all of the events we've ever done in this, I think, kind of a format, and probably even not in this format, I think this might be a record. So we're really excited, and we're hoping that the content that we're going to be, am I spotlighted? Let me see here. On the Zoom. Can somebody confirm? There we go. Perfect. Okay. Perfect. Okay. Wonderful. Thanks. Great. So really appreciate it. Thanks for joining. We're hoping that because there's such a big turnout and because there's such a lot of requests for a recording, we're hoping that this content is going to be valuable and applicable. F5 certification is one of those things that we've always had a lot of questions on. We'll definitely be touching as much as we can on the topic, specifically, of course, on the 101. As Chelsea had mentioned, that survey at the end will be your ticket to get your Uber Eats voucher. It may take some time. We're not sure exactly how much time for that voucher to come through. Don't know if it'll come through in time for you to use it today for lunch if you're on the West Coast. But I would think hopefully you'll have it so you can use it hopefully tomorrow. We'll have to see. But I think it's only like 3 questions. It's really short. And we look forward to getting your feedback and using that feedback for future sessions, right? And we're going to be talking about that quite a bit as well, that, because it's a very different world than it was before, and for some other reasons, which we'll touch on as well. We're definitely doing more in this format. I know many, if not most, if not all of you probably have Zoom fatigue to some degree. And we will be back on the road. And we actually have already started doing that in some degree in certain scenarios. But we definitely would like to complement that with this kind of a format for a couple of different reasons, like I said, that we'll touch on. So, yes, F5 101 Application Delivery Fundamentals is the name of the session. The vast majority of the session will actually be going through the exam blueprint that's been documented and published on F5's website that outlines point for point all of the various topics that may be covered on the exam. The version of Tmos that this class was written for is 13.1. Yes, that is the most recent version. Has not been updated in a few years. I think a big part of that is because F5 for the past few years has evolved quite a bit. And I think they kind of felt like as soon as they came out with new courseware that it may already be outdated to a certain degree. So, definitely everything that we're going to be talking about here today is fundamentals. And the fundamentals, at least as far as Big IP is concerned, haven't changed a lot. The fundamentals in the big picture have changed. We're going to be talking about that quite a bit. Because I think it's very important to understand the larger context of application delivery and how the big picture all kind of comes together. But this is an event for you. This is specifically for state and local government education. We sent this invite out far and wide so that way folks would be able to participate and start to gain value from these types of things. So just like it says here, welcome. We're glad you're here. We're glad that there's a lot of interest in this, and we look forward to bringing you more of this in the future. So let me click on that so I can change the slide. Now, to that point about other events, maybe similar to this, coming up, there are actually 2 events coming up very, very soon. One is actually coming up tomorrow. Both of them are on a topic called SSL Orchestrator. So they both have a slightly different slant to them. The one coming up tomorrow is focused on using F5 SSL Orchestrator for managing and orchestrating your security stack. So firewalls, IPSs, DLP systems, proxies, sandboxes, you name it, right? You have a security stack, most folks do, that introduces a relatively decent amount of complexity in managing that security stack. So we're going to be talking about how SSO Orchestrator helps manage the complexities of that stack. And then coming up in January 12th, also on the topic of SSO Orchestrator, but focused more on its ability to be able to provide visibility to encrypted threats. So by offloading the encryption both for outbound and inbound traffic, providing visibility to encrypted threats like ransomware, for example, which I think is very applicable because of the recent Apache vulnerability. I actually heard yesterday that actors are already starting to weaponize exploits against that Apache vulnerability to be able to launch ransomware attacks, right? So definitely very timely content. So if you can make it, there are two links. Actually, those are not clickable for me right here. So I'll tell you what, if somebody maybe on the CARAHCAST side is able to drop those links into chat, that way everyone has, looks like Chelsea's working on that right now. So yeah, if you're able to attend those, please register and we look forward to seeing you. All right, very good. So with that in mind, couple of poll questions before we get started. One of the key things that we really want to accomplish today is make this session interactive, especially because it's over Zoom, right? That makes it very challenging to stay awake. I mean, I'll be honest with you, I'll attend Zoom sessions and it's just nonstop, right? It's Zoom fatigue. So we want to make this interactive. This is one of the ways that we're doing that. We'd like to get your feedback, right? We'd like to better understand your organizations and your challenges. And we actually have two poll questions here. And if we can find a way to be able to show the results at a certain point later. I'd like to kind of wait to show the results until we get to a certain point, but we'd like to maybe collect the information now. So the first question here, I think should have already come up on the screen. If this did not come up on your screen, please let me know, but it's really just a question about Kubernetes, right? Kubernetes is for container orchestration. There's several different flavors or distributions of Kubernetes. And we're just curious if your organization uses any of those, right? So we'll give you a minute to answer that. Kubernetes is a big deal. We're seeing it all the time these days for modern applications. So it's highly applicable, and even in government education, it's really, there's always sort of a curve there from the commercial sector to the public sector, but we're definitely seeing in the public sector quite a bit. Okay, so with that, we'll go to poll question 2. Does your organization run application workloads in multiple locations, right? So what we mean by this is you have applications. Those applications probably have multiple components to them. Do you host or do you have different pieces of those applications hosted on-prem as well as public cloud? Or, if they're monolithic applications, which aren't broken up into multiple pieces, do you use public cloud for some applications? Do you use on-prem for other applications? Or do you potentially use multiple clouds, right? Do you have some things in AWS and Azure? So it's a very open-ended kind of a question. We're not looking to dig into details here, but just curious, right? Of course, everything used to be in the data center. That's the way it used to be. Things have evolved. We all know that, right? So just out of curiosity, do you have workloads in more than one location? So, all right, very good. And like I said, we'll share the data on that in a little bit. Okay, let me go back and change the slide here. All right, so let's talk a little about me. Won't spend a lot of time here, I promise. But I think it always helps kind of break the ice. And for those, I think I have a lot of my customers on the call. I cover state and local government as an SE with F5 for the Southeast US. And I think a lot of the folks that we do have on the call here are my customers. And thank you for joining. I really appreciate it. For the rest of you, we appreciate the opportunity to connect with you, right? You're in other parts of the country. Just a little bit about me real quick, and and kind of what my interests are, just to kind of personalize this a little bit. I enjoy cooking over fire. It's just my passion. I'm not always good at it, right? But I always learn from my mistakes. This is not my picture. In fact, I forget to take pictures a lot of times of what I cook just because I'm in the middle of something like watching a football game. But at any rate, that's my passion, whether it's smoking or grilling or you name it. And my wife always yells at me that I have too many grills and too many smokers, but that's my hobby. Of course, I live in Tampa, so you can't not be a Bucs fan and live in Tampa. There's this bum called Brady that, love him or hate him, he is who he is, and I'm a big Bucs fan. This is my wife. Excuse me. This is my wife's dog that she picked out, right? Her and the kids picked out this dog. It's funny, I almost said this is my wife. I had to make sure and change that very quickly. This is our dog Lucy. She's about 3 years old, and we love her to death. And my son actually set up this picture of her. So she's a nutball, but at any rate, we love her to death. So that's just a little about me. I do want to emphasize one thing before we start getting into some of the content, which is why you all are here, not to listen about me. The first thing I want to be clear about is that nothing that we're going to be talking about today is quote unquote official training sanctioned by F5, because F5 does not actually provide any sort, and we do not have any sort of official courseware for certification preparation. We do have training classes that are official, but those are, even though there's a lot of information in those training classes that do apply to certification, we do not have any courseware that's specific to certification itself. So just in the interest of making sure that we put that disclaimer in there, there may very well be content in here that has changed and we're just not aware or anything like that. So if you do encounter anything like that, please let us know, so that way we can update the material. But just wanted to put that disclaimer out there real quick. Okay. Yes, we mentioned this a few minutes ago. This absolutely will be recorded. Share it with your colleagues. If you're sitting for the exam, it would be good to kind of go through it again. Probably fast forward through all my mumbo jumbo here in the beginning as far as housekeeping goes. But we'll be sharing that link with you after the session. Okay. The next thing, be curious, right? Ask a ton of questions. We are doing polls. We're just trying to make this as interactive as we can. So you have a Q&A box you can drop questions into. I don't know if the panelists are able to answer those questions directly in the Q&A box. They may actually end up dropping the answers into chat, but we have several folks on the line, which I'll introduce in just a moment. They're going to be just completely rocking it today with answering your questions and helping me out a great deal, because it's just hard to do two things at once. We are going to be doing some giveaways for those of you that are able to accept them. I know within government education, sometimes there's some rules about that. I think the dollar amounts on these giveaways are probably under the threshold for that. But if there's certain questions that come up and our panelists think that those are just, you've knocked it out of the park with the question and it's very applicable and very relevant, and it's just something that we think all the participants will benefit from knowing the answer to that, they'll say, hey, be sure to pick a prize. We'd like to thank you for participating. Okay. All right. Wonderful. Oh, so Athena confirmed that they can answer questions in Q&A and chat. So I think there was a little bit of question on that, and now we've confirmed. So you will get the answers to your questions in chat. If they're answerable. If they're not answerable, we'll either have your SE follow up with you or something to that effect. Now, all of that out of the way, I want to introduce you to these rock stars that we have on the team with us. Me, I'm in the Southeast. I'm based in Tampa, obviously, based on what we talked about. We also have Brad Scherer on the line, who covers the Mid-Atlantic US for state and local government education. We have Nilesh Mistry, who covers the New York City, New Jersey area. Jay Pena, who covers New England. Tony Hayes, who covers the Midwest. Shannon Wilson, who covers Alaska, where it's very cold, I'm sure, as well as the Pacific Northwest. We have Leanne, who covers Northern California, Nevada, and Hawaii. And we have 2 open patches right now for state and local government education, which do not currently have SEs assigned. Feel free to reach out to any of us. If you're in one of those geographies and you have any questions, we'd be more than happy to help, or connect you to a resource that can help, right? This is a long-winded way to say that we are one team, and that didn't always used to be that way. Basically, there were some big changes that went into effect on October 1st at F5, and all of the SLED folks that handled SLED accounts were sort of scattered throughout different organizations within sales. Now that's all been collapsed and organized into one business unit, which actually rolls up to a new public sector business unit. So federal and SLED both roll up to public sector. And the net to you and why that matters is because there's a ton more focus at the corporate level on SLED. We know state government, local government, and education has unique challenges. There's unique use cases, and we're super, super excited to be able to provide new avenues like this, right? To be able to inform, educate, and partner with you going forward. There's probably going to be additional marketing dollars now that we're actually an official business unit. So at any rate, we're super, super excited. One of the things that I did want to be clear to mention is that in the couple of months that we've been planning this event, we've kind of had some thoughts about what the future of this kind of thing would look like, right? Because I didn't want this to be a one and done. I didn't want it to be, okay, we, give you the information on the 101 exam and, that's really it, and move on to the next thing. I wanted this to be more of a ongoing way to be able to work with our customers, right? Obviously, for day-to-day sorts of things, you have ways to contact us, email, phone, what have you. But as an ongoing thing, I thought it would be interesting to be able to have something like this, which would be something akin to like a national F5 SLED user group, where our customers have the ability to participate, not only to receive content that may be valuable to help them in what they're trying to accomplish within their organization, but also potentially have our customers deliver content back to us and to the other members of the SLED community. If you have a particular use case that you've used F5 technology for, if there's a particular area of F5 technology that you feel like you're pretty good with and you'd like to share that knowledge, we welcome that participation to be able to partner with us and just help bring the community together at large from a SLED standpoint. So we're super excited about that. We're thinking maybe quarterly is kind of the cadence that we're shooting for right now, even though this particular session is not called a user group. That's kind of the intent that it evolved into, because we don't want it to be a one and done. We want it to be an ongoing sort of a thing. Okay. So that's our who's who in the zoo. Okay. I just talked about this ad nauseum, right? Our focus is you. So I think enough said on that. We're here to help. We're here to help 100%. Okay.
Reed, real quick, will you be sending out the slide deck afterwards?
I'm not sure. I know that the slide deck is going to be part of the Zoom recording.
Yeah.
That's probably the preferred mechanism for the content will be within the Zoom recording. The content is going to evolve. Clearly you have all the content in the Zoom recording and you can just fast forward to a certain area that you're looking for. I don't know that we're actually going to share the PowerPoint itself. That's still sort of up in the air. If we can, and if we feel like that's the right thing to do, we'll absolutely do that and let you guys know. It's just there's certain complexities with that we haven't quite worked through yet. So that's kind of where we are.
Thanks, Reed.
Yeah, totally. So Wonderful. So we'd like to, kind of phase into the next part of the session here. We've been talking about how F5 is evolving from a SLED standpoint, right? It's very topical that we talk about now how applications are evolving. Applications are evolving just like crazy, right? I think a lot of us on the call, if not most of us, know and see firsthand exactly what's going on with applications. And whenever you talk about application delivery fundamentals, which is again what we're all here to talk about, I think it's important to zoom out a little bit, and that's what this slide is really trying to illustrate. We want to zoom out of the specific focus on one thing within application delivery, right? And talk about the big picture of applications. We want to talk about A, what is application delivery? B, why does it exist? Why is it important? And of course, how applications have evolved, like I just kind of touched on, right? So this is all the why. And whenever I listen to a vendor talk, oftentimes they're saying, we have the best such and such, it has these features, you're going to love it. And then I ask myself the question, if they don't answer the question already, which a lot of times they don't, is, but why? why do I want that, right? And so that's kind of what I want to talk about here, is the why, the context, the big picture. And then with that understanding in mind, then I think the specifics of what's going to be on the exam is going to be much more applicable. Also, the areas outside of that exam, which hopefully we'll have more content on in 2022, we'll touch on the other areas of application delivery, right? So what is an application? I'm not going to read this. And I kind of hesitated putting this on the screen, but I think at the very bottom, it has a very relevant, succinct way to put it, right? More simply, an application is an assembly of lots of elements across the user, network, and server environments. I think there's a perception that an application is only consists of the code that's actually running on the server, right? But it's more than that, right? There's elements from end to end, from code on the server to the customer or the user, right? There's elements throughout that entire flow, if you will, right? It's not just the code running on the server in the cloud or in the data center. It's the window into the business data, a business's data and acumen, right? So it's really the big picture. It's really the end-to-end stories is what an application is. And for years and years and years, applications have been what they call 3-tier, right? And I think many of you probably know this already. Again, a lot of this is not new, but 3-tier applications were just the way applications were designed for years and years and years, right? You have a presentation tier or a web tier, which sits in the front, that also talks to a logic tier or an application tier, which is in the middle. That's the second tier. And then you have a database tier, right? Pretty simple. You have ways to be able to scale each of these tiers through load balancing, which again is something that is important. But applications and application delivery is much more than just that, right? So you have the 3 tiers, but where is application delivery, right? Application delivery itself is not in this diagram. It's not in this basic representation of what an application is. And the reason why application delivery is not in this diagram is because this diagram was invented by developers, not operations folks that need to manage it in production. Okay, that's very, very important. The developer sees this, and in a vacuum, this is how an application works. But we all know the real world is not a vacuum. Therefore, application delivery is how you operationalize an application or all of your applications within production, right? So then the question is, where is application delivery? Where does it exist? If it's not in the diagram, how do I know where it is? Well, it's actually in a lot of places. Application delivery can exist within the client. for example, could be JavaScript that is pushed into a user's browser to protect them from certain types of attacks, as well as be able to identify them and even protect the application that they're connecting to, right? Application delivery can exist at the edge. If you're familiar with the concept of edge computing, CDNs are a type of edge, right? We all know application delivery can run at the edge, provide services at the edge, and just provide the mechanisms for which applications can be operationalized in production, and all of that goes along with it. Application delivery can exist in front of the workloads, right? And when we say the workloads, just it's wherever code is running. Workloads could be running in the cloud, could be running on-prem, could be running here, could be running there. Application delivery, this is where people think, I think, commonly of application delivery, especially with F5 and big IP, sitting in front of the workloads. And as well as Nginx, right? I want to be sure and mention Nginx Plus can also sit in front of the workloads to provide application delivery, but it can also exist within the workloads, right? Within the servers themselves, right? Nginx, I think a lot of us know Nginx is the most prevalent web server on the planet. And of course, Nginx Plus is the F5 supported variant of the open source version of Nginx. And it does more than a web server, a reverse proxy, all sorts of other use cases that it can be used for. And Nginx also has a what's called Nginx Unit, which is an application server that can integrate with Nginx and provide application delivery at much closer to the workloads themselves. In fact, they're actually on the server, right? So the answer is all of the above, right? Application delivery exists within all of these things to be able to operationalize and effectively allow organizations to run production enterprise applications without all of the issues that you would have without application delivery, right? So without application delivery, this is just a sample of the challenges without application delivery. I'm not going to go through all these, but just suffice it to say that it's extremely difficult, if not impossible, to operationalize applications in production without application delivery. Just like for those of you that are familiar with Kubernetes and how it relates to containers, imagine trying to have a microservices application within containers in Kubernetes, within containers in Docker, but not have an orchestration system like Kubernetes to manage all of the complexities, right? That's kind of what we're talking about. So that being said, I'll pause for a moment. Along comes this thing called cloud computing. Right? We talked about 3-tier applications. That's just the way applications have been done for years and years and years, using what they call waterfall development to be able to develop those applications. I think we have a slide on that's going to touch on that. But this thing called cloud computing kind of turned everything on its ear. I read that Bezos had an executive summit at his house in 2003 where they came up with the idea of, hey, we have organically invented some technologies within Amazon to be able to be extremely efficient, like to the extreme, right? Very, very efficient to be able to have a successful business operating at the profit margins that they operate at. They have to be efficient. So they created a lot of organic technologies that they use within Amazon to be able to do that. And they said, hey, why can't we take those technologies and make them available to other folks? And that's kind of how AWS came to be. And it was launched a few years later. So in that regard, there's this thing that I think a lot of folks see, and they see the cloud is coming, they see the disruption and the changes that are taking place with the cloud. And it's kind of like the space program, right? When there was a space race in the 60s where Soviet Union and United States were trying to get to the moon. And to do that, the United States just poured a ridiculous amount of money into the space program to be able to accomplish that goal. And in the process of such an advancement in technology, there was all sorts of these innovations that came out of that, right? The ones that come to mind, crazy, Tang, obviously, I don't drink Tang. I don't even know if it's around anymore. But the one I always think of is Velcro. At least, I heard, don't know if it's true. I haven't done a bunch of research, but I heard Velcro came from the space program. And I'm a big fan of Velcro. I use it for lots of things. So, all of those sorts of innovative things came out of a very disruptive kind of an event. And that's kind of what we're talking about with cloud computing. All of these sorts of things like containers and auto scale and intelligent insights and analytics about the applications, right? Automation and orchestration, modern authentication, very, very heavy use of APIs. These are all things that modern applications have in common, specifically coming from cloud computing, right? We touched on how three-tier applications are developed. They're using this waterfall methodology. This is what developers use to develop applications. And as things are changing now to more modern ways of doing things, based on some of the technologies that I just described, the new way developers are developing applications is what they call Agile methodology, right? It's very different. There's no beginning and no end. It's a constant loop. With waterfall, it was one of these things where there was a process for which code was improved upon, right? You'd have a new version of a monolithic application. That's what three-tier applications are called, monolithic applications. You have a new version that comes out. It goes through the waterfall process, ends up in production eventually, and then it sits in production until the new code is developed, the new version is developed, and it's a big chunk of code that's developed that goes through the waterfall process, gets testing and QA and all that, and then eventually ends up in production. It's very slow. The Agile methodology is very fast. Instead of doing large changes that take a long time, these changes are very, very small. That's kind of why microservices are the way applications are moving into the future. Okay. So we have monolithic applications on the left. We have microservices-based applications on the right. When we talk about microservices, we're talking about oftentimes containers, again, within some sort of an orchestration system like Kubernetes. And effectively what it comes down to is, instead of all of the different pieces of the logic tier of an application being all bunched up together, and if you need to make any change there, it's a very difficult thing to do. The different functions within the logic tier of the application are all broken up. Each one has a separate microservice, potentially a separate container, and it provides the mechanisms for which to be able to iterate new features and all of the things that just bring a ton of value to the modern day and doing things faster and more efficiently, right? So how does this relate to SLED? How does this relate to government? How does it relate to education? Well, it's kind of going back to what we were talking about, right? Amazon had a lot of cool internal technology that made them amazing at what they do. And then, of course, they opened up a lot of that to the world with AWS. And a lot of organizations, like we see here, this article in this blog, how can government deliver an Amazon-esque service experience to constituents, right? So that's just kind of the question. And I don't know that there's any one answer, but it's just kind of a question to be thinking about, right? How can governments and schools and universities start to benefit from these modern technologies? And that led to what we call digital transformation. I know this is a corporate buzzword. We're not going to spend a bunch of time on it. But digital transformation has to do with, instead of IT supporting the business, IT is enhancing the business and optimizing the business, right? So that's what digital transformation is all about. Started in the commercial sector, it's moving into the public sector very, very quickly. And the reason why it has moved into the public sector for government and education so quickly is this little thing called the pandemic, right? The pandemic basically made a lot of government and education organizations realize how fragile their legacy systems were, right? They see things like unemployment. And I think probably everyone on the call knows the struggles that unemployment has had since March of last year, right? Legacy systems, there was just no funding to modernize them. And quite honestly, up until maybe 5 or 10 years ago, there wasn't a lot of technology advancement, right? But once the cloud hit, that started snowballing, and you have this hockey stick of innovation. Now this makes a lot more sense. Plus, there's a lot of federal funding coming into government and education to be able to help modernize. So digital transformation is a big deal. This is the why that we were talking about. I had Ryan Reynolds up there, but why? This is the but why. So hopefully that makes sense. I know this is very complex. I know that we've touched on a lot of things, terms you may know, terms you may not know, but ultimately what it comes down to is F5 wants to kind of take where we are now and help organizations move into the future, right? I don't want to make this a commercial, but I do want to just very, very quickly mention this is the new F5, right? A lot of you on the call have used F5 for years. You think of F5 as big IP. Big IP is not going away. In fact, it's actually going through a metamorphosis right now to be even better soon. But it is one part of the picture. In order for applications to be adaptive and really be able to participate in digital transformation to optimize and enhance the business, and when we say the business, of course, governments are not for profit and that sort of thing, but we mean the organization and the mission of the organization. So when it comes to simplifying complex architectures, if you have workloads running in multiple places, you're probably looking for a way to simplify that because each of those clouds has a different way of doing things and it's just complex. F5 now is all about making it simple. Hasn't always been that way. We know big IP can be complex. The new F5 is all about simple. A lot of the things that can help with that are here now. A lot of additional things are coming. So we're really excited about the future. One way I like to look at this is all of the different streaming apps that are out there, right? You have Netflix, you have Amazon Prime, you have Paramount Plus, you have, you name it, right? Everyone's got a streaming app. And it's like, okay, well, what show is playing on what streaming app and how do I get it and how much does it cost? And that's kind of a similar paradigm to what we have today with different workloads running in different locations, right? We have workloads running in this cloud, we have workloads running on-prem, we have workloads running in a different cloud. They all have different, unique complexities and how do they talk to each other and all of that. This is the future of F5. The future of F5 is all about applications, putting them front and center, removing the complexities, and helping them optimize the business. Okay. Stay tuned. There's more coming on that. This is a fundamentals course, right? But we wanted to talk about applications, where they were, where they're going, and how F5 plays a role in that. Okay. Now we've talked about where is application delivery, what is application delivery. Let's talk about who is application delivery, right? Because application delivery touches so many different business units within the organization, DevOps has a role in application delivery. App dev, right? We talked about Nginx unit, right? Has a role in application delivery. Cloud architects have a role in application delivery. Site reliability engineers, NetOps, of course, security operations, many more personas within the organization. That's a big part of the reason why we wanted you to extend an olive branch to your peers to invite them to this session. So that way they heard the message, they kind of understand. I know they already understand where applications are going, but what they probably don't know is where F5 is going and how that can help their mission and their charter. So at any rate, work with your peers. I know a lot of times I've heard that there's challenges between silos within government organizations working with each other. Do what you can, right? Reach across the aisle, work with your peers. If you have DevOps folks, if you have folks in any of those roles that we just talked about that you're able to foster relationships with, to be able, it's just going to enhance things going forward because applications have evolved. And unless the organizations that manage and host those applications evolve, it's going to be a very difficult road. Best thing to do is kind of understand that the world is evolving, And like I said, reach across the aisle, work with your colleagues, and look forward to a future where everything just works so much better. So at any rate, we're going to try to share some of the poll data here. I don't see a poll button on my screen. It might be something that Carasoft has to. Chelsea, do you have the ability to put up the poll data for the first poll?
Yes, let me get that up here.
Perfect.
Is that showing?
Yep, it is.
Okay,
it is.
perfect.
So I think the data on this represents kind of what I thought. Certainly, I'd say a fifth roughly of the participants are aware of some sort of a microservices project within the organization, within a container orchestration system, some variant of Kubernetes. And then others probably not. But again, that's not super surprising, because there's always a curve. There's always kind of a lagging indicator with government and with education. So I would say, even if Kubernetes and these other variants of Kubernetes is not something that you've heard about, just be aware this is where applications are going, right? So in terms of the end-to-end story of IT participating in that end-to-end story, Kubernetes is the future. People do not develop new applications to be monolithic. It takes too much time. It's too slow. It's just not practical anymore. All applications these days are developed in a microservices architecture, and that is the future. So good data. Appreciate everyone's feedback on that. Can you put up poll number 2? All right. Does your organization run application workloads in multiple locations? Oh, I left an S off locations in the question, but I think y'all get the idea. This is just, yeah. I mean, clearly, there's a lot of complexity with what's going on these days and where those workloads live. You're probably hoping that there are ways to improve that complexity. So there is a ton of complexity there. I can appreciate the position you're in managing that. It's just good information, good to know, and we appreciate the feedback. All right, very good. See if I can change the slide here. Okay, great. So with that, I just like maybe to pause for a second. I wasn't quite sure when I was building the slide deck if there was going to be a lot of questions leading into the transition of the next section of content. Looks like we're kind of good where we are right now as far as questions in chat. So I just put that in there as like a pause slide, and we'll move on from there. So with that, I want to zoom in now. We zoomed out. We talked about the why. Yeah, go ahead.
We did actually have a question that just came in.
Oh, okay.
Let's see. What would you say to an organization that's aware of things like K8s, but is I went away. Okay, but is trying to use it as a way to run monolith applications, not micro anything, thinking they'll save money because they're cheaper than full virtual machines and cloud environments?
That's a great question. I don't have a very robust answer to that. If any of my colleagues on the line do, we can certainly, have them kind of give their thoughts on that subject. If not, what I'd like to do is loop in maybe after the call one of our cloud architects, and we can certainly kind of talk about that. Do any of my colleagues, Nilesh, do you have any thoughts on that?
So I'll just chime in quickly, right? So Zachary, a couple of things, right? Yes, you can absolutely run, a monolith application in a container environment or a pod environment. Doesn't necessarily mean that you have to run it as a microservices, right? And there's nothing wrong with doing that. Actually, that is your first step, because sometimes your monolith applications, you need to modernize them. And the first step to modernize is not to break that application itself and make it into microservices. The first step might be to just make sure that the application actually runs in a containerized environment or in a cloud environment or in Kubernetes. And once that's established, then you start figuring out as a step 2 to, break it down into microservices if possible, maybe function as a service or AWS Lambda, whatever they call it. So basically learn to walk before you run. So to answer your question, Zach, there's nothing wrong with that approach.
Makes all the sense in the world. Appreciate that, Nilesh. Thank you. All right. With that, we'd like to zoom in now, right? Let's talk a little specifics about the certification, right? So 101 certification, it is the first step in the journey. If you are looking to take a journey, or your journey can just be the first step. I mean, that's totally up to you where you end the journey. But the 101 is the first step. Application delivery fundamentals, that's what we've been discussing. Everything up until this point is not on the exam, but again, very, very important in the big picture to kind of understand where things were, where things are going. From here, the 201 for the customers on the call would be the next step. For our reseller partners, we have a 202. But for you guys, for customers, 201 would be the next logical step. That's a big IP administrator, big IP at the platform level. And then there's some LTM specifics in there, but it's mostly focused on the platform. And then from there, you can choose to specialize in any of the various modules that do run on big IP. And then from there are expert options as well. So yeah, great. Absolutely, Shannon. That would be Zach's question would be a great question for Swag. So yeah, definitely. See if you can get him hooked up with some goodies. Okay. All right. So with that in mind, for the 101 first step of certification, F5 publishes what's called a blueprint. And like I said, 13.1 is the current version of Tmos that the topics in the blueprint are based on. If you'd like to see the blueprint and get, see the whole thing, there's a link to it down there. Let me see if I can. Yeah, I'll tell you what we'll do if one of my colleagues, it's not clickable here, but if one of my colleagues is able to put that into chat, that'd be great. Yeah. Okay. So Nilesh already did that. So if you're looking for a copy of the blueprint, that's a clickable link. So you can actually go out there and see the blueprint published. Okay, great. All right. Very good. Now I want to be clear about something. What we're going to be talking about today is very fundamental. This is the fundamentals course. I know many of you have been using F5 for years, and you may feel that you'd like to get certified, which is great because it definitely helps, and this will be the first step in the journey is the 101. For others on the call, maybe they're F5 specific colleagues within their organization invited them, and maybe they're not in a role that touches big IP right now. These are fundamentals for 101 certification. If you'd like to pursue certification, or if you'd like to learn more about the fundamentals of big IP itself, we welcome you to continue, and we would value your feedback in the survey. But I want to set expectations, right? The rest of this content is specific for the exam. It's very fundamental. About 40% of the topics on the exam are not even really F5 specific. I kind of think of this kind of like a Cisco CCNA, or if there was even an exam before the CCNA. That's kind of what this is, right? A lot of the content is just generic industry specific topics, not F5 specific. And when we get to those areas in the blueprint, we're going to kind of gloss over them because I think a lot of folks on the call already know those topics. So we're not going to be spending any time on how to do IP subnetting, for example, right? I think everyone knows that. If you don't know it, lots of good information on YouTube. Go check it out. Okay, very good. Very good. Okay, great. So is there other free training available, right? If this is very high level, maybe I'm looking for something to supplement this. We do have paid courses that you can take. We do have future user groups, which are going to be providing some hopefully valuable content. But beyond that, we do have what we call the F5 Getting Started series. Again, it's not for certification, but if you're looking for more free F5 training, it's a great place to go. Again, it is a getting started series, so it's not going to get into the weeds, but it's a good place to go for more information on various topics. There's also a ton of good stuff on YouTube, right? Both published from F5 and also published from other folks. Just be aware, if it's published from other folks, there's a chance it may or may not be 100% accurate, but I think a lot of it is, and it's good content. So at any rate, free training, if you're looking for other free training options, in the 9 years I've been with F5, I'll tell you what, this is one of the most common things. You know, we don't have budget for training is what my customers tell me. I can't travel for training. If you have any free training, that's what we want. And that's again, one of the big things that we're trying to help with right here, okay? If you don't already have a lab environment for Big IP, I do recommend it. There's a lot of ways you can do it. And one of the easiest ways you can do it is with a lab virtual edition appliance or a VE appliance. It does have a maximum throughput of 10 megabits per second. So it is lab only. It's not for production. We've even seen times in a lab environment where that 10 meg is kind of a bottleneck. So just be aware of that 10 meg limitation. Does support up to 8 vCPUs. It includes most Big IP licenses, including LTM, DNS. It includes ASM. I presume it includes the ASM replacement, which is called Advanced WAF. It includes APM. It includes SSO Orchestrator and some other things. So fully included there. So VMware Workstation Fusion and VirtualBox are not officially supported. Many people have had success getting Big IP Virtual Edition to work within those types of virtualized workstation environments. It's specifically designed and supported for like ESXi VMware, vCenter, Hyper-V, KVM, and of course, public cloud hypervisors as well, AWS and Azure and that sort of thing. It's roughly $95 list price. It does have roughly a $20 annual support cost, which you do really want to have that annual support in order to be able to get upgrades. But it's super reasonable. Get your organization to pay for that. Hopefully that's, not too much for them to be able to do as an expense for you, so that way it'll help you better be able to manage and deal with F5 as a whole. You can get that a couple of different ways. You can get it from any reseller can sell you this, but I know that CDW has a real easy thing on their website where you can do it there. But any reseller can fulfill this this for you. Okay, structure for the exam. The exam, like I said, is based on 13.1. It is fully multiple choice. There's no true false questions. There's no fill in the blank questions. There's no lab questions. It is not adaptive in nature. So the scoring does not change based on based on how you've done. 80 questions in 90 minutes. So keep that in mind when you're kind of pacing your timing. You have just over a minute per question. Something I wasn't aware of, but it does say here that non-native English speakers have an additional 30 minutes. So I guess that would be a good thing for those folks. No command line engines. You will have to know a few TMSH commands. They're very limited, very few. We're going to touch on a lot of those that you're going to need to know. View the whole exhibit before you close them, right? A lot of times the content scrolls off the page and you need to scroll down to see the content. Manage your time effectively, and you can flag questions and come back to them. And I think there's some more exam tips that we're going to have at the end of the presentation here. There are multiple attempt rules. So the amount of days you have to wait after you take the exam, this probably won't apply to most folks. So this is all published on our website. So if you have questions on that, you can see it. To register for F5 certification, getting started on the process, the first step would be to go to certification.f5.com, log in, create an account, and fill out the form. You'll get an F5 certification ID number. Okay, and that's what you're going to log in with, right? Is your login ID in that certification portal. You'll receive an email with your Pearson VUE ID, and then you follow the instructions from there to be able to schedule the exam. Okay. Again, all of this will be in the recording. I know we're talking about a lot of stuff here, a lot of details, a lot of links and URLs. This is all going to be in the recording, which you'll have the link for, and you can always refer back to it. Okay. Additional certification resources. This is huge. Okay. These LinkedIn groups are very helpful, I've found. It's kind of like this, right? Since this is going to hopefully evolve into a user community, the F5 groups in LinkedIn for certification are kind of like a user community focused on certification. So do you have any certification questions? That's an excellent place to ask those questions. There are F5 employees that do moderate that, but there's a lot of other folks talking about the exam and their experience. They can't, of course, mention specifics on the exam, but I think a lot of the information that they have is very valuable. Okay. Any questions on the, getting a certification ID or any of that process? I just wanted to pause for just a moment. Doesn't look like we have a ton of questions coming in here. So with that, we'll go ahead. Again, if there are any questions, we'll take verbal questions at the end. Put your questions into chat, and we'll be sure. And oh yeah, Nilesh, $135 is the cost. I forgot to mention that, unless that's at the end. I don't remember if that's at the end or not. So $135 for the exam is what that costs. Okay, section 1 of the blueprint. Okay, objective 1.01 of the blueprint. Given a set of requirements, configure VLANs for big IP, right? Again, not rocket science. This is pretty straightforward. There are a couple of examples within that topic on the blueprint. Doesn't mean you're going to get questions on these example areas, but this is just some examples they have on the blueprint of types of things that you might get questions on, right? So VLAN tagging, MAC addresses, that sort of thing, right? So so when it comes to VLANs, the way you configure VLANs within a big IP is an object, right? There's an object called a VLAN. Back to the point earlier, if you've used F5 for a while, this stuff is going to be very fundamental. But VLAN is one of the first objects you're going to create. It has a name, and you're going to assign this VLAN to an interface. And it can either be tagged or untagged. Untagged basically is kind of similar to if you think of an access VLAN with Cisco, right? And a tagged VLAN is kind of like what Cisco calls a trunk. Yeah, a trunk. So sometimes I get those confused in my head myself, right? So tagged VLANs is basically an interface that allows multiple VLANs to travel across that interface. So you have, this is F5 terminology. This is the terminology that they could use on the exam. Untagged and tagged VLANs are objects that you assign to interfaces. Okay, this is kind of what it looks like in the GUI. This is a big part of the reason why I do recommend setting up a lab. Definitely, get a look at the GUI so that way you understand what these screens look like. But this is what the VLAN creation screen looks like in the big IP GUI. You can see here, you can choose tagged or untagged, and the interface that it would be associated with. Okay, and of course, the VLAN tagging is industry standard 802.1q. All right, let's see here. The next slide talks about the TMSH commands that would be used to create a VLAN. Now, when it comes to TMSH commands, I really don't think it's necessary to do a bunch of memorization on individual commands for this exam. What I probably would recommend is just kind of understand how TMSH commands are formatted. And based on that, you can probably answer any TMSH question that you're going to get on this exam, because this is a basic exam. They're not going to throw a bunch of complexity at you. So you get into TMSH by typing in TMSH from the shell on Big IP, from the bash shell. Then the first part of the command is either create or show or list, delete, or modify. And again, this section of the exam is all about creating VLANs, so it's going to be create. There are a couple of next pieces of that command, right? /net would have anything to do with networking, right? So VLANs, self IPs, routes, anything layer 3 related or layer 2 related is going to have a /net in the command, right? So create /net VLAN, and you see the rest of the command is pretty self-explanatory. So as long as you kind of understand the format of the command, you'll be able to answer virtually any TMSH question. You're not going to see a bunch of them, but that's kind of what you should expect on the exam. Now, from a TMSH standpoint, I mentioned show and list commands. I mentioned show and list commands in addition to create, and of course you have modify and delete. The difference between show and list, they kind of sound similar. Show is all about statistics. So if you want to see statistics for something, it's a show command. If you want to see object relationships to an object, that's going to be the list command, right? So just keep those in mind. And if you kind of understand the concepts behind the commands and kind of how they're formatted, you can probably answer any TMSH question without actually doing a bunch of memorization. Okay. That's more TMSH stuff that I'll kind of jump over here. Now, big IP trunks, right? We talked about Cisco trunks a moment ago, which are analogous to F5 tagged VLANs, right? F5 trunks, unfortunately, just a terrible naming convention because everyone knows Cisco trunks. It's not the same thing, okay? Big IP trunks is link aggregation. Okay, so LACP 802.13 is the default for that. It's just basically grouping multiple interfaces into one logical group, link aggregation. Okay. Now, this particular bullet in the blueprint doesn't talk about self IPs, but I'm going to touch on it real quick because it's an important topic. And I don't know if there's self IP questions on the exam because I don't have a list of all the exam questions, but you know, they may ask you self IP questions just because it's a pretty fundamental sort of a thing. So self IPs are the IP addresses you're going to be assigning to interfaces, specifically VLANs, right? So you have static non-floating self IPs. In the case of a standalone big IP that's not in HA mode, this is the interface you're going to assign. This is the IP address you're going to assign to the interface, and it does not change, right? It does not move. It's a static non-floating address. When you're doing high availability, there is a concept of a floating address. The floating address is what's going to be used to direct traffic to big IP and from big IP in an HA pair. And that address potentially could float between the active and the standby in the pair. Okay, so a floating self IP is an HA IP address that the big IPs share, right? And could go back and forth. Static is specifically uniquely assigned to a specific big IP. Okay. This does list some of the kind of what if you did a list net self TMSH command, this is kind of what that would show you. Again, if it was a show command, it would show statistics, but we're doing a list command, so it's going to show you attributes of those objects. Okay. Again, there's the GUI of what self IPs look like in the GUI, just so you can kind of visually understand what that looks like. If you were doing it in TMSH, again, that's all right here. It's going to be in the recording. Again, I don't think memorization is going to be necessary for TMSH commands, but just kind of understand the format and you should be okay. Port lockdown, I will briefly mention this. Again, it's not in the blueprint. It is something that has to do with self IP, so I'll just briefly mention it because there's a slide on it in the content that I have. This is basically a security mechanism for your self IPs. So you have the ability to lock down self IPs from traffic accessing it, right? If you say allow all, that self IP will not block any traffic destined to any ports on the self IP. If you say allow none, it will allow no traffic to that self IP except for stateful return traffic that's been sent by the big IP. Okay. If you want to say allow custom, for example, in this drop-down list that we see, yes, as Shannon said, don't do allow all. Please don't do allow all. Allow default is the default, as the name implies. There's a couple of commonly used big IP ports that it's going to be open, it's going to be listening for. Again, default, all, none, and custom. If there's only certain ports you want that self IP to listen to, you could say allow custom. Now, again, these are not VIPs. These are not virtual server IP addresses for application traffic. One example of why you might want to use this would be, if you had a need to SSH, for example, into the box, and you can't do that via the management interface for whatever reason, right? Maybe it's in the public cloud and it's a single NIC deployment and you don't have a management interface, right? You only have a single NIC, so you would need to allow custom, allow a specific port, and that sort of a thing, right? So you would do port 22 for allow custom, right? That sort of thing. Objective 1.02. This is super high level. I mean, explain the function of a router, firewall, and a switch, and interpret network diagrams, something I think the vast majority of you can do in your sleep. If you have any questions on this, there's a ton of information on the internet, and there's some high-level descriptions on this slide that you can review in the recording. Okay. Objective 1.03, given a set of requirements, assign IP addresses. Okay. Assign IP addresses would be the self IPs. I guess that it was actually in the wrong section. That was something I didn't catch when I was going through these slides. So the self IPs were what we were talking about for assigning IP addresses. That would be applicable here. Pardon me. But in order to do that, you need to understand IP subnetting, right? So of course, IP subnetting is important. I'm trying to remember back when I took this exam, there may be a subnetting question on there, but I think all of you know that. All of you know subnetting. Understand public and private multicast addressing, the various spaces for IPv4 IP addresses. Explain the function and purpose of NAT and DHCP. Again, pretty basic sorts of things. One thing that's worth noting with NAT is, of course, you have destination NAT and you have source NAT, right? And of course, you have static NAT and you have dynamic NAT. Static NAT always NATs to the same address. Dynamic NAT typically uses high ports to be able to do dynamic address, multi-SNAT connections, multi-NAT connections to a single IP address, right? So kind of a many-to-one relationship versus a single-to-one relationship with static NAT. A lot of information online that talks about that. It's not F5 specific. F5 does do SNAT. We do NAT. We do dynamic. We do static. All of those sorts of things. But this is all high-level industry stuff. There is a bullet in here about IPv6. I don't ever remember seeing IPv6 questions on the exam. And to be honest with you, in my opinion, this is not really a fundamentals question. This is not a fundamentals bullet. IPv6 I consider more of an advanced topic, even though, yes, everyone's been saying for years and years and years that IPv6 is going to supersede IPv4. Hasn't happened. It's out there. It's good to know. There are a lot of organizations that use IPv6, so I'm not saying it's not important. I'm just saying probably not on the exam. Oh, Leanne remembers an IPv6 question. We can't give specifics, but yeah, if you can, Leanne, if you want to maybe describe your impression of that question at a high level, just vaguely, just so everyone kind of understands.
So you just have to understand the basic 10,000 feet view of what IPv6 is.
So not on the addressing itself, just the concept of it.
Concept and the addressing, like the format, like it's a 64-bit
Gotcha.
number, and how it looks like the different format that you can come across.
Yeah, and of course it's hexadecimal, versus dotted decimal format with IPv4. So it's just a different representation of course, a much longer address. So
yeah, so they don't let you, they will not give you a subnet and say, okay, what are the hosts and what are the networks on an IPv6? Let's put it that way.
awesome. Awesome. Cool. Thanks, guys. Appreciate it. Objective 1.04 talks about identifying a valid MAC address. MAC addresses are 48 bits in length. Again, I think a lot of folks on the call understand what a MAC address is. Consists of two parts. You have a vendor section and a specific section that's unique to the interface. Trying to see what's here. Could be represented a couple of different ways, as we were just looking at. Could have colons between the octets. It could have dashes between the octets. It is hexadecimal. And again, this is what it would look like if you did an ifconfig command in Linux. You could see the MAC address that way. In Windows, you could see the MAC address in the network connection details. Pretty basic stuff, right? The next section talks about ARP. I think everyone understands what ARP is. Oh, I said 64. You're right, 128. Thanks for correcting me. I appreciate it. Yes, 128 bits. That is correct. That is correct. Versus 32 with IPv4. So ARP, right? So ARP is just a relationship between the MAC address and the IP address. Devices are going to ARP in order to be able to communicate on the network. It is strictly a layer 2 construct. It stays within the broadcast domain, the layer 2 broadcast domain. And that's essentially what it is, right? You have an ARP request from one host to another across a layer 2 broadcast domain. You have a reply, and that's effectively what that is. Again, more information on ARP on YouTube. If you want to learn more about that, it's in the blueprint, so that way you can keep track of the topics. You may get questions on well-known ports, port ranges. The Osi model, right? Again, these are all generic sorts of things. Ports range from 0 to 65, 535. You have well-known ports, which are below 1024. Everything above that are typically high ports that are used for establishing connections out, right? You have the OSI model, right? OSI model, pretty straightforward. I think everyone knows this. Layer 1, you have cabling, right? These are just electrical pulses. Layer 2, frames, Ethernet, Wi-Fi runs at layer 2. The internet is based on layer 3, which is packets and IP addresses. The session layer, that's where SSL and TLS live, right? And then of course you have presentation and application, which is the reason why F5 exists, is all about applications, right? Optimizing applications. Well-known ports, you may see some of these on the exam. 20 and 21 for FTP, SSH, SMTP, DNS, clear text HTTP, HTTPS. These are all kind of good to know, right? I would probably, if you're going to do any memorization, this might not be a bad thing to memorize, but you probably already know it anyways, right? Since it's not an F5 specific sort of a thing. The only one thing on this slide that is F5 specific is iQuery. iQuery is an F5 specific protocol and service, and it uses port 4353. So don't know if you're going to get an iQuery question. You might, but just be aware of that. Okay. Routing tables, I think everyone probably understands what a routing table is. Yes, Big IP does have a routing table. Routing tables are unique per route domain in the Big IP. So you probably won't get a bunch of questions on, yeah, layer 8 is bureaucratic. You're right. Yeah, absolutely, you're right. Perfect analogy there, Matt. But routing tables, you have a Big IP routing table per route domain. You're probably not going to get any questions on that, but you just need to conceptually understand why a route is needed, which is to get a packet off the network, right? Can't get off the network without a route, without knowing how to get there, what the gateway is to get there. You need to know what hops are, right? You need to know, given a destination IP address and a routing table, which route that's a match for, right? So you would see a route and you'd be able to kind of match that up. And again, I am glossing over a lot of this because it is not F5 specific. This is a good one that you might see some questions on. I think if I remember correctly, I think I remember seeing some things that kind of look similar to this where you have two hosts separated by switches and routers. And what does that frame look like at each step of the way, right? That frame is going to change. The addresses in that frame, both the MAC addresses and the IP addresses potentially. Well, actually, the IP addresses are not going to change. The MAC addresses are going to change from one step to the next. So just be aware of the relationship there from one hop to the next, and what MAC addresses may change and how that might look. Okay. Now we are going to start talking about some things an hour and 19 minutes into the class that are specific to big IP. And I apologize, that there's so much generic stuff on the exam, but I want to make sure just everyone knows that stuff is there. Now, for big IP specifically, Objective 1.06, they want you to understand ADC application objects within LTM. So we're talking about virtual servers, we're talking about pools, we're talking about pool members, we're talking about nodes, we're talking about monitors. We're talking about potentially profiles. Profiles add functionality to a virtual server that virtual server doesn't natively have, right? Like an HTTP profile or an SSL profile, for example. I do have a note here. When I was going through these slides, I noticed that in the F5 LTM and Tmos operations guides that we have, and we publish those on our website, there is some good information on a lot of these topics that we're talking about. If somebody wants to remind me either at the end of the session, or if one of my colleagues can drop some links into chat for those operations guides, there is some really good information in those operations guides that is very applicable to a lot of these topics. And this is one of the objectives that I think has some good information there. So, so I would definitely download those operations guides and check them out, because it does talk about each of these objects and really helps to kind of solidify this knowledge for you. Okay. So when we're talking about, let me jump back up for a second here. I don't want to give this short shrift. Virtual servers are the listener, right? So because big IP is a full proxy, it needs a listener to be able to accept traffic into the device. It's default deny by nature. So virtual servers are listeners to be able to enable it to accept certain types of traffic. And you configure that listener with a VIP to be able to accept that traffic. And that's what it's for. It's the main construct. It's the main object within big IP, and most everything else kind of attaches to the virtual server. The pools contain the pool members, which are the individual instances of the application that we're going to be distributing traffic to. And then the nodes are an abstraction of the pool members. So pool members consist of an IP address and a port number, right? So if you have an instance of an application that's in a pool and it's 192.168.10.10:443, right? Because that's the port number. So that would be the pool member, but the host or the node that pool member resides on would be the node. And it's just simply the IP address without the port number. And the reason for that is you might have one node that actually consists of multiple pool members. So just good to be aware of kind of the relationship between them. All right. Explain the features of an application delivery controller, right? So this is Gartner's term that really isn't heavily used anymore, ADC, application delivery controller, because application delivery is now so intrinsic within applications these days, like we talked about before. I don't know if I would necessarily call big IP an application delivery controller anymore. It is certainly an important piece of the end-to-end picture. I guess it kind of would be, right? But don't pigeonhole it into thinking that, that has a specific connotation to it. So kind of hard to describe what I'm talking about there. But at any rate, hopefully you get my drift. It says it's a network device, right? And that's probably what the test would say if it were to ask you a question on this. It is an application device, in my opinion, that happens to sit on the network, because because obviously it can't do what it needs to do without sitting on the network, but it's an application device. For the test purposes, they probably call it a network device because, again, it was written years ago, but it routes clients' requests for application services to the most available resource. So it optimizes, it enhances, makes applications highly resilient, high performance, right? From an optimization standpoint for performance, as well as secure, because security is intrinsic to the application. And that's kind of F5's view of security, is it should be intrinsic. So those are all things that an application delivery controller could provide. Of course, all has to be licensed to be able to support that functionality. And the benefits. So you have the features and the benefits. I guess what I just described was actually the benefits. The features would be like load balancing, reverse proxy, web application firewall, HTTP caching, HTTP compression. I guess I got those flip-flopped. So you have features, you have benefits. Of course, all of the features that I just mentioned play into the making it highly resilient, efficient, and that sort of thing. Okay. This is a diagram that we're not going to drill into too much here, but I did want to highlight what a floating self IP would look like. I don't know if you can see my mouse moving on the screen. I presume you can, but in blue, you have these IP addresses here. And then of course, down below, you have the self IP addresses in purple. Oh, you can't see. So if you look at the two big IPs, okay, cannot see the mouse moving. So if you look on the screen where the big IPs are there in an HA pair, you have blue self IP addresses above that. You have purple self IP addresses below them. The ones that are closest to the big IPs are the static local self IPs that do not float. And then the self IPs that are closer to the VLAN pipes in the diagram, 10.128.10.11 and 10.128.20.1. Those are the floating addresses. It does also show some big IP trunks between that VLAN and the big IP. You see that VLAN is actually trunked over multiple interfaces. That's the dotted circle around those lines. So if you're looking for kind of what that would look like on a diagram of what a trunk looks like. Of course, you have the virtual servers at the top of this diagram. These are the listeners that it's accepting traffic into, like we talked about before. It's going to be hitting one of those IP addresses and ports, and then those virtual servers are associated to pools, which consist of pool members, which consist of instances, specific instances for providing services for an application. Okay, you see those pools represented at the bottom of the screen. You have 3 instances of those applications in each pool. So each virtual server has 1 pool with 3 pool members. The big IPs do have out-of-band management. We kind of touched on that earlier. That's the preferred way to do that, because you typically, for security reasons, want to have your management on a separate network. And we do have a separate interface on there for management. So that's represented in red on the far left of the screen. But that's just a quick diagram of kind of what that looks like. All right. All right, very good. Within the GUI, there's also the ability to view a network map, which shows your virtual servers with the pools and the pool members. So this is just a quick way at a glance to be able to see the objects for each of the virtual servers, as well as the status of the objects. If you notice there, it shows in green that those hosts are up and those are running. This is a quick reference here that allows you to better understand what the colors and shapes mean. The only reason why they're shapes is because apparently I learned that from a user interface standpoint, we developed Big IP so that way if folks happen to be colorblind and they can't see the difference between those colors, they can see the shapes and they can understand the representation of the shape, right? So if you see a green or a circle, or a green circle, you understand that that's a good thing, right? That means that the health monitors that we're using to pull the pool members are successful and we're getting responses back and all of that looks good. If you see blue or square, you'll see that, that's basically most commonly a sign that you don't have a monitor assigned to that object, pardon me. in which case doesn't necessarily mean that the object is down. It just means it's in an unknown status, right? And that's most commonly because there's no monitor assigned to it. And if it's red, that means the monitors are failing. There's issues there. If you do see yellow, which is not shown on this slide, yellow is an interesting condition where that's basically if you have a virtual server. This is the only scenario that I can think of. There may be others, but if you have a virtual server and you configure a connection limit on the virtual server and that connection limit has been reached, it means the virtual server is up, but it's not accepting new traffic because that connection limit has been reached. So as soon as certain sessions start to age out, it will accept new sessions to fill those gaps. Okay, great. So we successfully made it through the first section. Just a quick poll question. Kind of wake everybody up for no other reason maybe, but what is a big IP trunk? I think a lot of you will probably be able to answer this. So we'll leave that up for just a moment and let you look at the options there. Logical grouping of interfaces, interface containing multiple VLANs, interface greater than 1 gig, or a logical group of self IPs. And with that, I guess let's go ahead and display the results. There you go. All right, so the majority of the folks do have that right. Logical grouping of interfaces, just like it showed on the diagram. Again, it's easy to get big IP trunks and Cisco trunks confused, and I apologize for that, but I can't fix it. So it is what it is. It's a logical grouping of interfaces compared to a Cisco trunk. A Cisco trunk is a interface containing multiple VLANs. So moving on, if I can get to the next slide. All right, very good. Okay, with that, I thought this would be an excellent time to take a 5-minute break. Since I wasn't quite sure how long this session was going to be, we want to just insert in here for everyone just to grab a quick cup of coffee, a quick drink, and meet me back here. I show a time of 2:31, and let's plan to be back at 2:36. All right. So section 2, troubleshooting. Again, you're not going to need to do anything super in-depth here from a troubleshooting standpoint. Pardon me, losing my voice. You will want to know the common HTTP error codes, as well as identifying reasons for methods of connection termination, right? Like a TCP reset, for example. And identify causes for failure to establish connections. So we'll talk about that here. Common HTTP status codes, you probably know about a 200 OK. That's what you want to see from a status code typically. That means everything's fine. The other ones I would probably just be thinking about are 302 redirects, right? 302 redirects are the most common. 301 redirects, not as common anymore. 301 redirects were developed so that way search engines could update their results based on a redirect. But I think 302 is just kind of the standard now for a redirect. 400 bad request. That means this client the HTTP client sends something the server doesn't understand. 401 would be unauthorized. So basically in that scenario, you have failed authentication, right? So if there was a challenge for HTTP basic authentication, which generally speaking has, kind of fallen out of favor. Most people don't use HTTP basic authentication anymore. But if there was a basic authentication challenge and it failed, the client would get an unauthorized. And forbidden means that they have been successfully authenticated, but they don't have access to that particular resource. So it's more of an authorization failure. Of course, I think everyone probably has seen and probably knows about a 404. It means the web server is missing the content that has been requested. So you clicked on an old link that doesn't exist anymore. And 500 errors are server errors, right? So if you see a 500 error, that means the site's down, pretty much is what that means. So 500, 503. Okay. HTTP methods. You have get methods, which is what a client will use in an HTTP request to request a resource, to request information. The other common ones that I would probably just be aware of are post. Post is probably the only one that they might ask you about. That's when you're sending data from a client to a server and you want the server to store that data. That's a post. There's a similar command called a put. Puts are what's known as idempotent. And idempotency has to do with the ability to have something, when you send multiple requests for the same thing, if something is idempotent, that basically means that you can send that request as many times as you want to, and it doesn't change the result on the server, right? If something is not idempotent, that server is going to receive and accept it multiple times. So idempotency basically means that the server knows that it already has that information, and it's going to essentially ignore additional requests that come in with the same information. Okay. The rest of those methods, not super common. I doubt they would ask, but it's good to be aware of. Let's see here. Given a scenario, verify layer 3 mapping. So, understanding the show commands. We talked about show commands earlier, right? There's a few of them there. Given a scenario, verify layer 2 mapping. There's a TMSH command you can use to see that. You can also see it in the GUI, but the TMSH command here would be show/net arp all, right? So we want to see statistics, and we want to see network statistics specifically. So it's going to be a show command and relationships. And of course, ARP would be the request that we're sending. All right. So relationship between the IP address and the MAC address. There is a blurb here about MAC masquerading. Don't know if this will be on the exam or not, but just my dog's going crazy in here. I apologize if anyone can hear that. Somebody locked her in the office with me. So MAC masquerading is basically the ability to, within a failover pair, when you have an active standby failover pair, it typically is a best practice in order to allow the failover process to work more smoothly. If you don't use MAC masquerading, in order for the other hosts on the network to know that they need to now send that that traffic to the new MAC address, right? Because if you have a failure, you have a new MAC address that has now accepted responsibility for that floating IP address that we talked about, the floating IP address, and of course, all of the virtual server IPs. So there has to be a gratuitous ARP that takes place. And sometimes there are issues with that gratuitous ARP. Whereas MAC masquerading, you actually set static MAC addresses that are used instead of the burned in MAC addresses from the vendor. So gratuitous ARPs aren't necessary. It's much more efficient, more reliable, and that's effectively what MAC masquerading is. Okay. Given a scenario, verify traffic is arriving at a destination. Packet captures are an important way to do that. You can do packet captures from the F5 shell using the TCP dump command. This is a very common sort of a thing. If you're an F5 administrator, you may have a need to do some troubleshooting. You may have set up a new virtual server and, traffic's not flowing like you expect it to. This is a good way to be able to see both sides of the proxy, because again, we're a full proxy. We have a client side of the proxy and a server side of the proxy, and you have the ability to be able to see on each side exactly what's going on at the network level, right, from a packet standpoint. So you can do a packet capture with TCP dump. TCP dump -I is a common way you would do that in order to filter specifically TCP dump for specific information coming in on an interface or a VLAN. And you can use an interface number or a VLAN name following the -I in order to filter specifically by that. And then, of course, you can use other TCP dump filters also if you want to. If you want to filter by by a host IP address or by a port number or something like that, of course, you can do that as well. Okay. It also shows in the GUI here where you have the ability on the sidebar in Big IP to click on statistics, and you can see statistics for traffic flowing, and that's ultimately what this topic of the blueprint is verified traffic is arriving at the destination, and you can see that in the statistics whether or not that's taking place. So these are a couple of different ways you can confirm that, right? Given a scenario, verify layer 1 connectivity. Well, like we touched on earlier, layer 1 all has to do with cabling and electrical pulses across the cabling, bits, if you will. The link light is probably the best way to do that. So you look at the link light, you see the representation on the link light, and that's going to tell you whether or not you have layer 1 connectivity. You can also log into the device and see the status of the interface. If the interface is up or down, you can do that within the GUI or within TMSH also. Okay. Let's see here, interpret ifconfig output, right? So the ifconfig command is a command that you can use. It's a Linux command that happens to be also used by F5 and Big IP. So one thing we didn't touch on that's actually important to know, at a fundamental level within Big IP, it consists of two operating systems because you have different planes of traffic within the device. You have what's called a data plane, which is what the clients and the servers use to communicate with each other. Traffic crosses that data plane, and you also have a management plane. The management plane is what that management interface is tied to, and it is run by Linux. So there's a hardened, purpose-built variant of I forget which distribution of Linux that we use for the management plane. But for the data plane, that actually leverages a microkernel operating system that F5 developed years and years ago. Very efficient, very high performance. It's called Tmos. And it is a microkernel, and one instance of that microkernel runs on every core in the device. So those microkernels are called TMMs, traffic management microkernels. They run on each core in the device, each CPU core. And there's a construct within Tmos and within the platform that actually takes traffic, and in order to make a decision on which CPU to send that traffic to, it flows through something called a disaggregator or a DAG. And you can think of a DAG like a load balancer, because that's effectively what the DAG is doing. The load balancer is distributing that traffic evenly across all of the cores, which makes the performance linearly scalable across multiple CPUs. So that way you don't have a point of diminishing returns. Like some platforms, when you add more CPU power to a device, it doesn't necessarily give you more performance, right? You kind of get to a point of diminishing returns. Tmos enables linear performance scaled across those cores through TMM and the disaggregator. So a lot of kind of inside baseball information there, but it is good to know. So when we're talking about ifconfig, this ifconfig command, that is a Linux command for the management plane. And in order to get from the management plane into the data plane, remember, you go from the bash shell to the TMSH shell, right? By typing in TMSH at a command prompt, and then that will take you into the TMSH shell. And then, of course, you can back out of it again should you need to. Okay. Explain potential layer 1 failure modes, right? So, who knows? Duplex settings, cables out of specifications, electromagnetic interference. You have faulty optics, which unfortunately, is more common than a lot of people think. Faulty SFPs and that sort of thing. But a lot of things can contribute to layer 1 failures. And in my opinion, I think layer 1's probably the most common issue of any kind. So that's one of the things that I think it's always good to check first is layer 1. Interpret if config output. Again, we touched on this. If you do if config at the bash shell, it shows you each of the interfaces with all of the appropriate information for those interfaces. And then, again, that's just straight out of Linux. If you've done Linux, you're familiar with that. Identify when drops are occurring. Best way to do this would be in the stats. You can either do the stats through TMSH or you can do it via the GUI. And if you go into the network stats, it shows drops as a column, right? So you see that column right there in the GUI as well as in the TMSH output. And if there are any drops there, it's going to show them to you. And you can see that it shows 0 right there. All right, very good. So that was the troubleshooting section. Not painful at all. Poll question real quick. Which 2 of the following can be used with the command tcp dump -i? So what we mean by this is following the -i in the tcp dump command, what 2 things could you type in next in order to filter the output of tcp dump for a packet capture? IP protocol number, interface number, TCP port number, or VLAN number. And we're talking about immediately following the I. That's what we're talking about, because you can filter on pretty much all those things, but immediately following the I, what's the next thing that you're going to put in there? And there's two choices, and I guess we'll give everyone another maybe 10 seconds to answer that. All right. So let's go ahead and show the results. Very good. So the 2 correct answers are the interface number and the VLAN number. So TCP dump -i. -i is a very common, very effective way to be able to filter output in a packet capture with TCP dump. Because if you don't filter it and you just type in TCP dump, it's going to show you every packet traversing the box. And whether or not it's in production, it's probably going to be more information that you can absorb. So it's good to filter. A good way to filter a lot of stuff right off the bat is with a -i, either with an interface number or a VLAN number. So good information there. All right. Moving on. Does anybody have any questions that haven't already been put into chat on that? Can you tell us again what the -i indicates? -i means interface. So it not only, I'm assuming that's an I, not an L. It's hard to tell in the chat there, but -i is interface. You can either put the interface number or the VLAN name, the VLAN object name in there. All right, very good. So the next section, maintenance. So maintaining a big IP at the fundamental level, the very basics of what you need to know. So given a scenario, review basic stats to confirm functionality. And again, we're talking about specific platform stats here. We're not talking about application stats. So one stat you could run as a show net interface. You could do show all sorts of things, right? If it's a network type of a thing, it would be show net again. If it's a box or a platform, I want to say box anymore because virtual edition appliances are very common now instead of hardware. But if you're a platform, if you're confirming functionality at the platform level, it would be show sys, not show net. Show net would be network based, layer 2, layer 3 types of things. Okay. There's a good link there in the presentation that takes you to the TMSH command reference that talks about the show command. There's also one in there for the list command, so you get some good ideas of things you can do to pull that information. Moving on to the next section. My dog's eating something here. I'm gonna Oh, it's something it's not allowed to have. Give me just a moment. Ugh. So the joys of working at home. All right, back with you here. So local traffic object stats. Within the statistics section of the sidebar on the left-hand side of the Big IP GUI, one of the tabs is local traffic. This is where you're going to see all of your application stats. So virtual server stats, pool stats, just all sorts of information regarding the local traffic object statistics. And you can see from there, you have a drop down, which is shown in this diagram. And in the drop down, you can see lots of different types of objects that you can drill into to pull up those stats. All right, very good. Again, you can also do it via TMSH. Because these are local traffic stats, it's not a show sys or a show net command. Remember, show LTM would be for local traffic sorts of things, right? So show LTM pool, and then the name of the pool in this case here. All right. The other thing that I wanted to emphasize as far as TMSH commands go, I know we touched on this earlier, but I just want to put a fine point on it. There's no fill in the blanks. Right? There's no fill in the blanks. It's all multiple choice. So if you're presented with 4 options, pick the one that makes the most sense. It's probably correct. All right. Good testing logic that I very commonly use. All right, very good. Given a scenario to determine device upgrade eligibility. Ooh, this is a big one. This is a big one, right? So you have an F5 device. And when we talk about upgrades, we could be talking about upgrading the code, right? Upgrading the version of Tmos, or we could be upgrading the platform itself, because platforms do have a certain life expectancy to them. And commonly I use the term refresh for that versus upgrade, just to, make sure and not confuse the two. But it's definitely one of these things where there's this tool that we have called iHealth that does make this a little easier. We used to have a thing on iHealth called the Upgrade Advisor. That's been deprecated. I think there were some issues with it. So instead of giving false information, they just kind of took it down altogether. But iHealth does have some good information in there. And effectively, the way it works is you export a support file from your Big IP. That support file is called a QK view. You can do that from the I believe it's called the system section of the sidebar. If you go all the way down to the bottom of the sidebar, click on system, within there, you have the ability to export a support file. That's a QK view. You can either, depending on your version of your Big IP, you can either automatically upload it from there, from the Big IP directly to iHealth, which is, again, within F5's environment, I guess, for lack of a better term. Or you could download the QK view out of the Big IP and then upload it to iHealth manually via the web portal. Once it's in iHealth, you have the ability to see some useful information, like if there's any known vulnerabilities with that version of code, as well as the important milestone dates. So it shows the important milestone dates for that version of code, as well as the platform, telling you when it's going to be going. The most important milestone that I would focus on is what's called end of software development. There's an end of software development date for both the version of code as well as for the platform. You want to make sure you're off the platform or the code by that end of software development date. The reason for that is because after that date, product development within F5 no longer tests new versions of code against that scenario, whether it's that version or that that platform, right? So it's important to get off of it by that date and try to stay relatively current with your software. Again, you don't want to be bleeding edge with your software, but you don't want to be old either, right? We see that more times than we'd like to admit. Is a lot of times the F5 Big IPs have been kind of forgotten about in the closet somewhere, and they're running code that's 7, 8, 9, 10 years old. And not only are there vulnerabilities, but there's all sorts of other things. You really want to kind of I would probably stay one major version behind whatever the bleeding edge is, right? So right now, I'd say bleeding edge is 16.1. 15.1 is a fairly comfortable place to be. Again, do your due diligence, read the release notes, make sure you understand the differences between your current version and that new version. If you have any questions on this process, talk to your SE. But for test purposes, QK view, understand end of software development, kind of what that means. Understand that you have the ability to open a proactive support case with support to let them know that you're planning to do an upgrade, and they're going to ask you to provide a bunch of proactive data to them. The reason for that is if you encounter an issue during the maintenance window with the upgrade, you have the ability to get a case going much, much quicker than if you had to get an engineer up to speed with all of your information, right? If you had to submit the QK view and submit all of your data and everything of what you're trying to accomplish, it takes a while to get over the formalities of opening the support case versus if you've already opened the support case, you've already uploaded the QK view, you've already done all of those sorts of things. A support engineer can jump in pretty quickly and they'll already be up to speed on exactly what's going on. So definitely recommended. We also have professional services that can help with upgrades. And when you're doing an upgrade, just keep in mind, if you upgrade the standby first, right, then you can fail over your traffic from the active to the standby after your standby has been upgraded. Then that allows you to upgrade the other box that used to be the active, right? And then at that point, both boxes have been upgraded. So in terms of minimizing downtime, there's a number of best practices. The operations guides that we talked about earlier, I think those have some additional best practices in them. This link, I think this link is something I added yesterday to the slide deck. If you look at the link at the very bottom of the slide, that's a support article. I think that's a relatively new support article that gets into some new best practices. Again, these tests were written several years ago, so whatever's in that article probably isn't going to be in the test. But you want to know more than the test. You want to know, you want to know all of the things that are important to know about how to maintain these in production, and that has all the latest information in that support article. Okay. Given a scenario, interpret the traffic flow. Right. So again, you have the ability to look at performance reports within Big IP. So clicking on statistics and performance reports allow you to view that information. That statistics tab just has a wealth of information in there to be able to just provide all sorts of information for troubleshooting and for maintenance, right? You can just get a lot of good data out of there. You could even turn on application analytics should you wish to do that. Does have an impact, some impact on the Big IP. And now that we have Big IQ, which is our off-box management platform, you have the ability to offload a lot of that heavy lifting for analytics to Big IQ. That way you can get a lot of insights and a lot of analytics and a lot of good data from an application standpoint in Big IQ. Okay. Let's see here. Given a scenario, interpret service status. We looked at this before. This is the network map, which shows you the various objects. You see the virtual server at the top of the list. In this scenario here, it's VS. Well, some of them say HTTP to start with, some of them say VS, but those are the virtual servers. Underneath those objects, indented, that's the pool, right? And then of course, indented within each of those are the pool members. And then you have the various statuses, red being down, health monitor failed, green being up, health monitor succeeded, blue is unknown status, health monitor probably has not been configured. The service may or may not be available. And if it's in black, that basically means that that particular object has administratively been disabled. That wasn't in the previous table we were looking at for monitor statistics, but black is going to tell you that an object has been administratively disabled. Okay. Infer services for given netstat output. Again, netstat is not an F5 specific thing, but you do have the ability to run netstat to see what ports are listening on the device. Yeah, and of course, this bullet goes with that as well, right? Determine whether a service is listening given a specific port based on netstat output. All right. Here is a more descriptive version of all of the monitor codes, right? So black does tell you that it's been administratively disabled. Gray means that an object is unavailable because one of its children objects, it's a parent, and one of the children objects has been administratively disabled. And of course, we talked about the others, right? So interpreting system health, QKView not only lets you get information that helps you assess it for whether or not you should do an upgrade, but it also provides good information on other facets of the health and just the ongoing caring of big IP. I would recommend not only uploading QKViews as often as you open support cases. I would actually recommend proactively uploading QKViews on a cadence, right? Get into a rhythm where you upload it. And I know everyone has many different roles going on right now. Sometimes it's hard to find the time for this, but an ounce of prevention is worth a pound of cure. And if you're able to stay on top of things like this, it does prevent some heartburn down the road. It's just like a car. You need to keep the car running. Doesn't require a lot of care and feeding to keep a car running, but you do need to change the oil. There are certain things that need done. So I would proactively upload a QKView to iHealth maybe every few months and just kind of go through the data and see how things look and just kind of make sure that, things are okay. If you ever have any questions on anything that's in iHealth, or if you'd like your SE to review that with you, we're happy to do that. Just reach out to your SE. We're happy to go through the QKView with you. Reviewing logs. We do have the ability to collect logs within the device, both through the GUI. Again, I believe that's the system section of the sidebar, which is at the bottom. You go there and you go to logs. You can see all of the logged events. Also, if you're trying to pull the text file logs, they're located in /var/log/LTM, right? There are other log files other than that, but that's, I'd say 8 to 9 times out of 10, that's the log file that you're going to be using to be able to find what you're looking for. So /var/log/LTM, but you can also get that from the GUI. Ensure efficacy of maintenance tasks, right? So make sure your alerting is set up if you have SNMP, or if you have the ability to do SNMP, make sure that's configured. Make sure your backups are configured. If you have a way to do scheduled backups, even better. Big IQ can do scheduled backups of big IP for you, so you don't have to think about it. That's all good to be doing to keep it healthy, if you will. And review system vitals, right? Your CPU, your disk space, your memory, all of that is going to be in iHealth as well. This just shows you how to create the QKView file. We kind of talked about that earlier. And this is what iHealth actually looks like. So it does have a screenshot in here where you can see, all sorts of valuable information, right? So lots of good information here that's going to help you keep your big IPs running strong. And if you ever have any questions on what's in here, let us know, please. All right. You can also get system vitals from TMSH, show sys CPU. Again, it's a show command. We want to get statistics. Sys is a platform level command. It's not LTM about applications. It's not about network, layer 3, layer 4, layer 2, layer 3 stuff. It's about the platform, the box itself. So if you want to review CPU utilization, you could do TMSH show sys CPU. You do have statistics that in graphical format, not only in the QKView and iHealth, but you do have them on the box itself. So if you want to see graphs of like CPU information, CPU utilization, that's in here. To do configuration backups, those are called archives. So if you look on the left-hand side under System at the bottom of the sidebar, there's an option under that that says archives. This is what you want when you're collecting a local config file archive for your own purposes, right? So if you need to keep copies of the configuration archives as a safety net, as a backup, again, I would do this periodically. That's how you do it. It's a slightly different process to export a QK view, but it's still in the system tab down there. Trying to look to see if it shows it. Yeah, I think it's off the bottom of the screen actually to run a QK view, but at any rate, this is how to create a UCS archive that's a local configuration backup, includes all of the config files, but it also includes some other things like your SSL certificates and your SSL keys, right? Because that's all very important information. All right, very good. Let's move on to the next poll question. What does an object status with a blue square represent? And can we put that poll question on the screen? We'll give everyone a minute to read the options there. If anyone wants to see what my dog did, I don't know if you can see this, but I have an empty bottle of vitamins that was already empty. Apparently it started chewing through the bottom of it. So if you have a dog, you know what I'm talking about. So anyways, all right, let's bring up the poll results.
Sorry, getting there.
No worries.
Yep.
All right, very good. The availability of the object is unknown, and the object is enabled. It's a very long answer. Yeah, so it actually goes off the screen, apparently. Yes, but basically...
Yeah, but if you want me to read the complete one, it actually says the availability of the object is unknown and the object is enabled, commonly due to no monitor configured on the object.
There you go. Perfect. Perfect. So, yep, that is correct. Looks like most of you got that right. If you have an object and there's a monitor in place and that monitor, that monitor is not in place, right? The status of the object is unknown. So we just don't know what the status is. It's not down. It may respond, it may function. We just don't know because most commonly that's due to, I think there might be a couple of other corner case scenarios where it's blue also, but the vast majority of the time it's because there's a monitor not configured. All right, very good. Very good. All right, moving right along. I think we're in the home stretch here. So section 4, I think this is the last section of the blueprint. And this is going to be some stuff that's fundamental, right? ICMP, right? I think everyone knows about ping. I think most people probably know about TTLs, right? So time to live with packets. Basically, this is a lifetime that the packet has as it's traversing the internet based on number of hops. And if it exceeds that number of hops, it's discarded because we don't want packets just floating around forever. So that's the purpose of an IPTTL. An HTTP keep alive. This is interesting. So from an HTTP standpoint, again, a lot of you probably know this, but from an HTTP standpoint, there's different versions, right? I think the first version was 0.9, back in the Netscape days, and then 1.0, 1.1, and then of course HTTP 2. And I don't think HTTP 3 has been ratified yet, as far as I know. But at any rate, as far as keep alives go, what we're talking about there is HTTP 1.1, which is a very common, for years, it's been a very common, stake in the ground that people use for an HTTP version number. And basically, it was the first version that implemented this concept of an HTTP keep alive, which is basically where you have HTTP requests that are able to reuse existing TCP sessions, right? And that's much more efficient from a performance standpoint than having to do an HTTP request, response, and then tear down the TCP connection. And then if you have another HTTP request, you have to build a new one. That's just terribly inefficient, which is the way it was before 1.1. 1.1 added that ability to do keep lives. Explain the purpose of ICMP echo request reply. I think everyone knows that. If you don't, look on Wikipedia. And ICMP unreachable. I believe, if I'm not mistaken, that's actually what happens when the TTL is exceeded. An ICMP unreachable is actually the message that comes back to the sender. So that way they know the TTL was exceeded. All right. The OSI model, again, we talked about this earlier. This is actually a good chart that lets you kind of map everything out in your head to understand how everything relates to each other. But again, it's not rocket science, at least for those of us that have been in the industry for a while. So, you know, that is what it is. Protocol data units. For some reason, this slide does say commit this to memory. So it's possible one of the F5 folks that developed these slides saw a question on this at one time. So understand, you know, the different PDUs. Again, I think all of us probably get this anyways, but you know, the relationship between a bit, a frame, a packet, and a segment. Right. And you have an encapsulation process when you go from one layer to the next, where it encapsulates the bit in a frame, the frame in a packet, or excuse me, encapsulate, go in the other direction. It encapsulates the segment in the packet in the frame, and the frame in the bit. So well-known ports, we already talked about that. This is a good one. Let's talk about SSL and TLS, because even though it's not specific to F5, I think it is something that well, it's very complex, right? We're not going to be getting into the weeds, obviously, but at a high level, we do want to talk about, you know, public key, private key, symmetric, asymmetric encryption. At least it just kind of set that, you know, context for what those are. So when it comes to SSL, and again, at a high level, this is the common industry standard that's used, and it's actually not even called SSL anymore. It's called TLS. Most people still call it SSL just because that's what they call it. But it's the same thing. Just know that SSL formally has been deprecated. TLS, the old versions of TLS have also been deprecated. Current versions of TLS that are considered secure would be like 1.2 and 1.3. It commonly uses public key infrastructure, or PKI, to be able to facilitate how it does what it needs to do. And there's two functions here. You have an asymmetric cryptographic process, and you also have a symmetric cryptographic process. The asymmetric cryptographic process is what's used for both parties that are participating in the encrypted connection to agree on a key. Okay, they're looking to agree on a key, and you use asymmetric encryption to agree on a key. It's a secure way to be able to share information over a public connection like the internet without a static key. Problem with asymmetric and the way it does things is it's very CPU intensive. It's much more intensive than symmetric encryption, right? Because there's different keys involved. It's not a static key that's shared between both people. So effectively, the asymmetric process is used to agree upon a shared key, and then that shared key is used by those parties participating in the connection during the actual sending of the data itself, which is the symmetric process. Okay, so symmetric uses the same key. It's a shared key to decrypt and encrypt. Asymmetric uses different keys. Okay, so effectively, what's going to happen? See if I can explain this right in my head without confusing myself. The sender is going to, when they're doing asymmetric encryption, which is again the key negotiation process, the sender is going to encrypt something with his public key. Okay, that's sent to the recipient, and the recipient will then decrypt that with their private key. Okay, that's effectively how that works. All right. Let's see here. Self-signed certificates versus CA signed certificates. This is one of the bullets that they're mentioning here. So a CA is a certificate authority. Certificate authorities are trusted parties on the internet that issue trusted certificates to customers after some sort of validation where they can validate who they are. They need to authenticate who they are, and then they're provided a CA signed certificate that establishes a level of trust back to the root, which is that certificate authority. Okay, so that's a CA signed certificate, also known as public certificates. You go to Google, you go to any public website, typically that's going to be a public CA signed certificate. Self-signed certificates are not issued by a public certificate authority. Self-signed certificates are certificates that organizations can create on their own. And typically, web browsers are not going to inherently trust self-signed certificates or private certificates. So if you're going to issue self-signed certificates, you need to make sure that you establish some layer of trust and you add your own private CA certificate to your browser, so that way your browsers don't give your users error messages. You've probably all seen that where somebody's SSL certificate expires or there's something else wrong with it and you get a browser error. That's what's going to happen with a self-signed certificate if the browser does not have a root certificate in its certificate store to be able to tie that trust back to the root, right? And all the browser vendors, they put those root certificates within the certificate store within the browser, so that way the browser knows who they can trust, and anything outside of that inherently is not trusted, and you'll get the browser error. Okay. Explain the rationale for using TLS and SSL. Well, it's mainly for these reasons right here, which is authentication, privacy and confidentiality, integrity, and non-repudiation. I think privacy and confidentiality is probably the one that's obvious that most people think about, but the other pieces of this puzzle are very applicable, right? So that's kind of the whole reason why all of this exists. And the last bullet here on this slide has to do with how Big IP processes SSL and TLS traffic at a high level. And just at a high level, we talked earlier about the fact where Big IP is a full proxy. We have a client side of the proxy that establishes its own connection to the client, and then you have a server side of the proxy, which establishes its own connection to the server on the backside, right? I kind of like to think of this kind of like an air gap in a box to a certain degree, although a lot of people will probably argue with that analogy, but that's one way of thinking about it, right? Because you don't have a single connection that flows all the way through. You kind of have an air gap, you have a break in those connections. So from a TLS standpoint, you have a client-side profile, which basically handles all the negotiation between Big IP and the client, right? And setting up that TLS connection. In that scenario, Big IP is actually acting like a server, right? Because you always have a client-server relationship. You have the client on the client side of the Big IP, and then the Big IP has to act as a server, okay? But that is a client-side profile. So a little confusing there to think about. You kind of have to, take a step back, but client-side profile talks to the client, server-side profile talks to the server, and the server-side profile acts as a client to the server, right? So it's going to be establishing the connection on the backside to the server, and then handling that key negotiation from there. All right, very good. We touched on this, certificate chains. This is a chain of trust. This is why there's only trusted entities that issue certificates. Basically, we have to have some sort of a validation process that the only people getting certificates are the ones that have been authenticated by the CA, that they're legit, that they are who they say they are. That's the whole reason why certificates exist in the first place. And it's a chain of trust. You might have a scenario where you have a root certificate authority that also deals with intermediate certificate authorities. But if that's the case, you need to have the ability to verify all the way back to the root, right? So there's this chain of trust. The client trusts the intermediary, and the intermediary trusts the root. So it all kind of ties back as a chain. All right. So moving on from SSL and TLS, VPNs. I think everyone on the call understands VPNs. These have been around forever, right? We're really not going to get into this, but IPsec was how VPNs came to be. They're good today for site-to-site VPNs, not so good for client VPNs because they introduce an immense amount of complexity. Today, SSL VPNs are the way most client VPNs are done. There's a number of reasons why it's done that way, and they're in the bullets here, right? It's easier to deploy and administer. It's just better suited for that kind of a scenario overall. And the bullets do go into the details of that. Okay. High availability concept. So big IP high availability. We've already touched on a few of the different pieces here as far as high availability goes. But explain the methods of providing HA integrity. Well, you need to have multiple devices, right? And you need to follow the best practices from F5 and basically have no single points of failure. The methods to provide high availability, there's two primary categories, two schools of thought: active, and active standby. And I think it might blow everybody's minds here, but what I'm about to say is technically, from an F5 standpoint, these are the same thing. And the reason for that is both of these use a concept which is called device service clustering. Device service clustering is a method for which you have the ability to define what are called traffic groups. Okay. And traffic groups essentially represent a given application or maybe a set of applications that you want to exist on a given big IP within a cluster. And big IPs can be a cluster. You can actually have up to eight big IPs in a cluster. The most common scenario, I've never had a customer with 8 big IPs in a cluster. By the 99.9% of the time, it's going to be 2 devices. Active standby or active. Now, it's important to kind of peel that onion back, what that means, right? So if you're doing active standby, which I would consider the most common and the most practical, and probably in most scenarios, what I would recommend. And the reason for that is all of your traffic groups reside on one big IP, and they do not reside by default natively on the other big IP. And then if the big IP that has all of your traffic groups on it goes away, then all of your traffic groups fail over to the other device. Okay. You know where your traffic groups are. You know which application is processing traffic for your applications at any given time. It's a very easy way to kind of keep track of that, but it still uses the clustering concepts of traffic groups, right? If you do want to do active, what that means is you have multiple big IPs, and each big IP has active traffic groups assigned to it, okay? It does not mean that a given application has traffic flowing through both big IPs. And that's an important distinction, because I think in a lot of other scenarios outside of application delivery, active means something very different than it means within application delivery, right? I think within firewalls, you have the ability to have both firewalls be active and have traffic for a given client passing through both firewalls, right? That's not what we're talking about here. We're talking about an application within a traffic group. That traffic group can only exist in one place, either on device A or device B. If you want to have application 1 be active on the first device and application 2 be active on the second device, you could certainly do that. In my opinion, it introduces complexity because you never know. It's harder to keep track which applications are running where. It's also difficult, I think, from a sizing standpoint, because you have a distinct possibility of accidentally oversubscribing your pair, your cluster, because you have some services running here and some here. Let's say you start running 60% of capacity here and you start running 60% of capacity here. Well, if you have a failover and you need to fail services over, you need to take 60 from one box and put it on 60 on another box. You're now running 120% of capacity, right? So there's some complexities there, but that's what active-active means. All right. And the advantages and disadvantages, the pros and cons of high availability. Well, I mean, I don't think there really are any cons of high availability, although it's more costly, right? You got to buy 2 boxes or 2 platforms, pardon me. And, there's a little more complexity involved, but, there's a lot of pros, right? It just makes it much easier to do upgrades. If you don't have an HA pair and you need to do a software upgrade, you have to take an outage. There's no 2 ways about it. If you have an HA pair, you can upgrade your standby first and then fail traffic over, and you don't necessarily need to take an outage. You still might want to do it in the maintenance window and an abundance of caution, but you won't necessarily have an outage. Okay. Clearly, if you're doing active standby, you do have a box sitting there doing nothing most of the time. That's the downside. Do active standby, but it's a trade-off. Okay. We've seen that diagram before, but that's basically what happens, right? Active and standby switch places. Okay. All of these things I'm not even going to really get into, right? But I think everyone on the phone on the call knows DNS, NTP, syslog, SNMP. If you need to brush up on these things, Wikipedia, YouTube, and just kind of understand those concepts at a high level. There's a couple of different tools you can use for lookups, NS lookup for DNS as well as dig. NS lookup has essentially fallen out of favor. Dig is the most common way you do lookups now to be able to do troubleshooting and that sort of thing. So dig is a very popular and useful tool. And of course, curl, right? If you need to do HTTP troubleshooting, curl is a command line HTTP browser. I guess you could call it a browser. I call it a client. It's a command line HTTP client. Doesn't support JavaScript or any of those other fancy things, but it does a good job of telling you what the headers are, right? Make sure those are correct, as well as just kind of looking at things at a greater level of detail that you can see natively in Chrome without some sort of an add-on to Chrome to get some of this information. Okay, wonderful. Poll question. I think this is our last poll question, I think. What does a TLS sender use to encrypt a message during asymmetric encryption? So you're trying to set up a key exchange between 2 parties, and you have a sender that needs to encrypt a message to be able to do that key exchange. What does the sender use to encrypt that message? And again, sometimes I stumble over this myself, but I think eventually I come to the right answer, and I think most of you will also. We definitely talked about this. All right. So with that, let's go ahead and pull up the results. Okay. Bear with me a second. I just froze up. All right, very good. So right there, it looks like a lot of you have this correct. the sender's public key. It's sort of neck and neck between those two options there, but the sender's public key is correct. So the sender is going to encrypt it with his public key, and then the recipient is going to decrypt it with the recipient's private key. All right. Very good. Now, in wrapping up, we've gone through the entire blueprint. You pat everyone on your back for hopefully not falling asleep, and if you have, don't tell me. But we're just going to wrap up with a few things here that I think might be helpful if you're prepping for the exam. So I found a support article somewhere. I don't remember where it was. It may have actually been in one of the operations guides or somewhere, where it talked about the 101 exam, and it talked about the concept of what they consider a minimally qualified candidate to pass the exam. And there was a handful of bullets that they listed for a minimally qualified candidate. And I thought that was interesting. So I pasted that in here. The vast majority of this we covered probably ad nauseum. One of them, I don't think we did cover in what we had, but I wanted to call attention to it here, which is the one with the support article link next to it, creating a problem statement. So we talked about how opening a support case with support can be useful for proactive things, for assessing your upgrade, whether or not you should upgrade, QK views and iHealth, right? All of that sort of thing. When you open a support case, whether it's a proactive support case or a support case where you actually have a break fix issue and you need troubleshooting support, creating a problem statement is hugely important, right? Because the more descriptive that problem statement can be, the better equipped the engineer is going to be to understand what you need and really jump into the thick of it, with you very quickly without having to do a bunch of back and forth questions, 20 questions. And I see that quite a bit because I monitor some of my customers' support interactions, and it's, sometimes pulling teeth to try to get information to be able to help troubleshoot. So the more information you can provide up front, super awesome. That's called a problem statement. That link there is really good at describing exactly what support would like to have in the problem statement. So check that out. Don't know if there's questions on the exam, but it is possible. So, a lot of this we already talked about, but, are you, when you schedule the exam, are you a morning person or afternoon person? Schedule the exam accordingly. Prometric has been added as an authorized testing facility, which as of when this content was written, that was a new addition. You need 2 forms of ID. I think both need your signature on them in order to be able to sit for the exam at the testing center. Make sure you dedicate enough time for preparation. I think this will help. I think, setting up a lab in your environment, whether it's a virtual edition lab or some other mechanism, so that way you can get some non-production hands-on. I think that's very useful. But like we said, a lot of this stuff is stuff you already know, so it's really pretty straightforward. Answer all the questions the first time through. That's what the person that wrote this content recommended. And then, if you need to review that, you can do that. But only mark 10 questions for review at most. This is this person's opinion. So anyways, there's you can review this in the recording, right? I think a lot of you have probably taken exams before, so you kind of understand this. But if you do want to better understand the psychological part of taking the exam, definitely take a look at this. Information on the left side of the page we've already covered. Oh, it actually says it's $180 for the exam. So just be aware that it may cost more than the $135 that we thought. Yeah, this says $180 for the exam.
It is $180.
Very good. Appreciate that. Now, on the right-hand side of the screen, what this means is if you're looking at the blueprint, right? We put the link for the blueprint on the website in chat. If you're looking at the blueprint, you save a copy of that. Within the blueprint, each section has a letter in that section. It's either an R, a U/A, an A/E, or a C. If I remember correctly, the vast majority of it is either an R for remember the content or a U for understand and apply the content. So, because it's a fundamentals exam, it's more lower order thinking skills. If you see that, you see where it says low order thinking skills, higher order thinking skills with an arrow pointing to the right. There's no or very few higher order thinking skills on this exam. It's all relatively straightforward stuff. But if you see an R or a U/A on the blueprint, this is what it means. And if you kind of want to better understand that, it kind of tells you. Okay. Again, this is unofficial. If there is any errors in here, we apologize in advance. This is the map. Once again, if anyone didn't get a copy of this map and you want to do a quick screenshot on who your assigned engineer is, please grab it, use us and abuse us. I think everyone's going to hate me for saying that, but we wouldn't exist if it wasn't for you. So please, please, please reach out to us. We're happy to help. All right. Are there any questions that anyone has not asked in chat that you'd like to, if we'd like to open up the lines to ask verbally?
There was a question on if we have practice questions. I've never found any good set of practice questions. I've seen things out there, but I don't know that we have anything official.
I've seen things out there. There's definitely nothing official. I think I've seen some previous versions of the slide deck where, the person that wrote that content recommended them. I tried going to the site and I couldn't find them. So maybe they don't have them at that particular place anymore. I think there are some companies that do have sample questions out there. We can't speak to the quality of them, unfortunately. So
I shared a link in chat. It's to Exam Studio.
Okay.
So if you go there, it does have our logo, but I don't think it's not like ours official, but it does help you get ready and prep for the exam. It asks similar questions that you can encounter in the exam. And it's kind of like all your Cisco is similar to the Cisco practice exam. So give that a try. It is $25 per exam. So it's a mock exam.
Great. Very cool. Appreciate that. Good information. Last but not least, survey. We would love to make sure and get you guys an Uber Eats card. Fill out the survey. It's only 3 questions. We're just looking for, what you liked in the session, what you thought could be improved. Like dogs not interrupting me in the middle of the session. I apologize for that. Just give us your feedback, because like we said, we do not want this to have a beginning and an end. We want it to be an ongoing thing. And we want it not only to be a one-way conversation, we want it to be a two-way conversation. So please let us know what you'd like to see in future events. And with that, that brings us to the end. We appreciate everyone joining us today, and look forward to working with you in the future.
Yeah, thank you, Reed. That was a great presentation. I just want to thank all of our participants for joining us today.